Hi everyone, today let's learn some distinct problems on writing a regular expression. The first problem is obtain a regular expression for the language L is equal to a to the power n b to the power m where m plus n is even. The language L consists of strings in which there are n number of a's and m number of b's and a's are followed by b's. The condition m plus n is even means the number of characters in a string must be even. We get even length strings in two conditions. We should add a even number of a's to even number of b's, or we should add odd number of a's with odd number of b's. To get a regular expression for these conditions, let us take the first condition where m and n are even. That is, even number of a's followed by even number of b's. So even a's is represented with aa, and even number of any number of even number of a's means aa whole star. Similarly, even number of b's is bb, so that can repeat any number of times means whole star. So this is the regular expression for even number of a's and even number of b's. For the second case where we have to add odd number of a's and odd number of b's, the regular expression will be as a into aa star b into bb star. So as we already know that if we add 1 to the even number of a's, it becomes odd. Similarly, we will be adding one more b to even number of b's. So this is the regular expression for odd number of a's and b's, which together is going to form a even number of characters in a string. So the final regular expression will be aa star into bb star plus a into aa whole star b into bb whole star. The second problem we have is obtain a regular expression for the language L is equal to a to the power n b to the power m where m greater than or equal to 1 and n greater than or equal to 1 and n into m greater than or equal to 3. M greater than or equal to 1 means minimum there should be 1b in the string, and n greater than or equal to 1 means there should be minimum 1a in the string. N into m greater than or equal to 3 means the length of the string should be more than or equal to 3. So we have three possible cases. So for the first case, as we need to have n into m should be greater than or equal to 3. So if we keep m is equal to 1, then n value should be greater than or equal to 3. So n is the number of b's and m is the number of a's here. Hence, the regular expression is triple a star b. So triple a satisfies n equal to 3 condition, and greater than 3 will be represented with a star, and m is equal to 1 means 1b here. Similarly, for the second case, since we need to have n into m greater than or equal to 3, if we keep n is equal to 1, then n should be greater than or equal to 3. So the regular expression is a into triple b, that is n is equal to 3 condition, greater than 3 will be satisfied by b star. N is equal to 1 means we have 1a. For the third case, as n into m should be greater than or equal to 3, if we have m greater than or equal to 2, then n value should be greater than or equal to 2. So for this condition, the regular expression is m is equal to 2 is satisfied by 2 a's and greater than 2 is satisfied by a star. Similarly, n is equal to 2 is satisfied by 2 b's and n greater than 2 is satisfied by b star. So to get the final regular expression, we need to add all these regular expressions like this. The next problem we have is obtain a regular expression for strings of a's and b's containing not more than 3 a's. The condition not more than 3 a's means at the maximum there can be 3 a's in the string. That is, there can be no A or a single A or two A's or three A's present in the string, but not more than three A's. So we can write a regular expression for this condition as epsilon plus A into epsilon plus A into epsilon plus A. So maximum there can be 3 A's, so we have written 3 A's here, and each A can either be present or may not be present. So that is represented with epsilon. So there is no condition on B. There can be any number of B's in the string. These B can be added at all possible places as shown between the regular expression epsilon plus A into epsilon plus A into epsilon plus A. So we'll be getting the final regular expression as B star into epsilon plus A, B star into epsilon plus A, B star into epsilon plus A, at the last also B star. Obtain a regular expression for the language L is equal to A to the power n, B to the power m, where n greater than or equal to 4 and m less than or equal to 3. Means the language is consisting of strings of A's and B's, and A's are followed by B's, and the number of A's should be greater than or equal to 4 and the number of B's should be less than or equal to 3. The regular expression for the condition n is equal to greater than or equal to 4 on A's is 4A's minimum, so greater than 4A is satisfied by A star. So similarly for m lesser than or equal to 3, so maximum there can be 3 B's here, so each B may present or may not be present. So as we have seen in the previous problem, so every instance we add epsilon plus B into epsilon plus B into epsilon plus B. So for maximum 3 B's. Hence the final regular expression is A's followed by B's. So this is the regular expression for A condition. This is the regular expression for B condition. Next problem we have is obtain a regular expression for the language L is equal to W, where number of A's in W mod 3 is equal to 0, where W belongs to A comma B whole star. Number of A's in W mod 3 is equal to 0 means the number of A's in the string should be divisible by 3, or we can say it should be a multiple of 3. So the regular expression for this condition is triple A star. So that is multiple of 3's. But there is no condition on the number and position of B's. So we can add B's at all possible positions as we have seen in the previous problem. Hence the final regular expression is given as B star A, B star A, B star A, B star whole star. The last problem we have is obtain a regular expression for the language L is equal to VUV, where U comma V belongs to AB whole star and the length of V is equal to 2. The strings in the language are of the form VUV and the length of the V should be 2. Means we get 4 possible combinations with A's and B's, that is AA, AB, BA and BB. There is no condition on U, and U is a combination of A comma B whole star. Hence we can write the regular expression for U as A plus B whole star. According to the format given, that is VUV, the regular expression can be written as AA, that is beginning and ending with the same V here. So that is, first we have taken A, then we have taken AB, then we have taken BA, at the last BB. So if we write the regular expression according to this form VUV, this is the final regular expression. Hope you guys understood. Let's meet in our next video on Kleen's theorem. Thank you.